Let's take a look at examples of the chain rule, and again we're using the chain rule to find the derivatives of composite functions. So our first example, we have 1 over 3x squared plus 1 quantity squared. So this is a composite function, and we can look at it as, actually, there's two ways of looking at it. One, we can look at it as 3x squared plus 1 is our innermost function. So I'll call that g of x. Then that we can look at as being squared. And then that we can look at, that this thing squared we can look at as being in the denominator. But what I'm going to do is actually rewrite this first as 3x squared plus 1 to the negative 2, because then it's just two levels. It's g of x in here, and then f of x is the, x to the negative 2 power. So the derivative is going to be deriving the f of x part, the negative 2 power. So I bring the exponent down as my coefficient. Then I reduce the power by 1, so I make that a negative 3. Then I plug g of x back in completely unchanged, so 3x squared plus 1. Now I need to multiply by g prime of x, which is going to be 6x plus 0. So that means if I want to kind of clean this up a little bit, I could write it as 6x, or actually I could write that as 3x over 3x squared plus 1 to the third power, and then put my negative sign in. So again, we looked at the outer part, f of x, then we did the inner part derivative afterwards. Second example, sine cubed of x. This one in some ways is a little bit more straightforward because it's easy to see that the sine here is my inner part and the cubed here is my outer part. So f of x is equal to x cubed, g of x is equal to sine of x. Let me actually go back on the previous one and label those for you as well, if that helps you to see it. So g of x is 3x squared plus 1. F of x is x to the negative 2. So that kind of corresponds with those bits. So coming back here, the derivative of f of x would be 3 times the thing squared, x squared, 3x squared. But again, we replace the x with the g of x, so that'll be sine of x. And then times the derivative of g of x, which is cosine of x. And in this case, there's not really much we can do to simplify it, so that's our final result. All right, our third example, we have sine to the 6th of x cubed. So in this case, we see we have a g of x as my, actually, because I know that this is going to be 3 layers deep, I'm going to just go ahead and start by calling this h of x. So h of x is equal to x cubed. Then I have sine of x as my g of x. And then I have an f of x equal to x to the 6th. If it's easier to see it, you can imagine this as sine of x cubed to the 6th. And that's sometimes, if it's particularly complicated, I'll rewrite using as many brackets as I can, because then it's sort of easy to see out working our way inwards. But our first function is that x to the 6th, so I'm going to get 6 times x to the 5th. And what is my g of x? It's sine of x, but it's not actually sine of x, it's sine of x cubed. So I'm going to write that there. Now I'm going to multiply by the derivative of g of x. Well, g of x, let me leave that in there. G of x is going to be, the derivative is going to be cosine of x cubed. Then by the chain rule, 3x squared at the end. So you'll notice I did the outer part, the x to the 6th, and then I just plugged in everything that was inside, so sine of x cubed. Then I need to multiply by the derivative of sine of x cubed, which if I do that, I get cosine of x cubed, but because of the chain rule, I get my 3x squared. So this is what happens when you do it multiple times. Using the chain rule is best learned by just practicing a lot of problems and then checking them with me, checking them with a friend, asking when you get stuck, and you'll develop an intuition for it. There is technically algorithmic ways you can work it. For example, writing it with brackets, but you're going to have your best luck by just working through it and seeing where you end up. So let me know if you have any questions, but otherwise we'll wrap up with that here.